Good afternoon, everyone, and welcome to the IIRSM Southeast Branch webinar for September 23, focused on indoor air quality and innovative air quality technology. My name's Matt Kent. I chair the Southeast Branch Committee, and I'm delighted to introduce Alpesh Trivedi from GPS Air Solutions, who's going to present to us today. About Alpesh, well, he's an enthusiastic, educated and experienced marketing and new business development professional. He's got a proven and long-standing experience in formulating and implementing key growth and new business development strategies. And he's experienced in the international environment and specifically within the HVAC and the indoor air quality segment. And also very keen to engage in new trends and supporting HVAC industry with a wide range of the work that he gets involved with. On a personal front, Alpesh has previously helped the organisation I work for pilot some indoor air quality technology. So I'm really keen to hear what Alpesh is going to talk to us about today. There will be an opportunity for questions at the end, so please use the Q&A or the chat function via your menu bar, and we will pick these up at the end of the webinar. On that note, Alpesh, thank you very much for your time, and over to you.
Yeah, thank you, and good afternoon. Thank you, Matt, for a great introduction. I think in terms of indoor quality, I would still say I'm still learning as the whole world evolves in indoor quality, but certainly it's the area I'm passionate about it. So again, thank you everybody and welcome to this session. And we'll look at some of the tools to how to enhance the indoor environment. My name is Alpesh Trivedi. I work with GPS Air and manage the business in the UK and Europe. So very briefly, in terms of what we're looking at, in terms of the contents, we briefly look at the introduction to air quality, growing awareness of IAQ and health impacts, what are the legislation and standards and the challenges, and then jump into a little bit about what's really the indoor air, what are some of the association and the guidelines for likes of WHO and other associations, quickly look at the filter selection standards and guidelines, and then look at specifically the ionization as an added layered approach, and overall IAQ as a continuous process. I mean, I always think one slide to introducing air quality is not enough, right? But very, very briefly, in recent years, concerns about the impact of air quality on human health, productivity, and well-being have intensified. As a result, poor air quality is now recognized as a significant factor in conditions such as coronary heart disease, lung cancers, asthma, diabetes, and even dementias and likes of so. In the UK, DEFRA uses something called Daily Air Quality Index to monitor the outdoor air quality, which really focuses on the 5 outdoor pollutants, which is measured across different sites in the UK, and some of them are listed here. There's certainly growing awareness of IAQ, and I hope most of you agree, and I would like to get some feedback at the end of the session. But increasing publicity around air quality and the COVID-19 pandemic of 2020 has also raised awareness and interest in IAQ among the general public, right? As a result, people are conscious of what might be in the air they breathe and how it might affect their long-term health. Various researchers have shown how the poor indoor air quality affects workplace and would affect their health and in short term and long term, right? So indoor air quality is directly related to general well-being and wellness of the employee or staff or visitors or anybody. I always get asked about, rightly so, what are the legislation on indoor air quality, and what do we look at it, right? So at the moment in the UK, there is no legislation which sets standards for indoor air quality. There are various guidelines, of course. For example, look at Part O of the building regulation, which was introduced in 2022. Although it sets higher standards for ventilation in new homes, it was introduced in 2022 to tackle the problems of overheating in increasingly airtight UK properties, and it's not directly to improve the IAQ. The lack of regulation creates a challenge for building owners and operators to understand what the good indoor air quality looks like. For example, like I mentioned in the previous slide, in the UK, there are measurements of outdoor air quality in place, like DEFRA, Department for Environment and Rural Affairs, provides a daily air quality index, which measures these 5 air pollutants across 1,500 sites in the UK. I've put a screenshot of PM 2.5 particulate matter. And this can be used as a representation for indoor air. So one of the results of this increasing of concerns in the UK is that the government has now begun the process of introducing a new clean air, or what is it called, Human Rights Bill 2. The proposed bill achieved its second reading in the House of Lords in December 22, and it's been debated since then in House of Commons during spring and summer 2023, and currently it's in second stage of reading. If introduced into law, the bill would update and combine several existing UK regulations on air quality, revise air pollutant concentration emission limits, and bring them into line with the most up-to-date World Health Organization quality guidelines. Importantly, these limits would also cover indoor air quality, making them the responsibility of building owners and managers. So it's something happening in the future. For example, if I may add, Brussels and Belgium end of last year, they passed a motion. From 2024, they expect all the commercial building to have some sort of IAQ dashboard. So this is something what is being, I believe, being followed into UK and other European countries. Sorry. So yeah, I mean, there are lots happening in IAQ. Some would say there are gaps in the IAQ regulations and standard, but certainly to address the gap in these regulations on indoor air quality, the global engineering sector is pushing forward with its own work on finding answers to those questions, likes of ASHRAE or British Council for Office, well in BREEAM standards, and very recent British Standard 40102, which specifically talks about overall indoor air environmental quality, of the building, and these really, provide basic elements of IAQ and guidance for the facilities team to establishing IAQ strategy. So these are those resources, some of the available, and you may be aware of more. And if you know, then do let me know in this session. But recently, I would just like to point out the BS 401 or 2 standard. It really, kind of captures the overall indoor environmental quality, which addresses not only air quality, but also things like lighting, thermal quality, acoustic systems, and so on. So looking at the overall performance of the building. So when we talk about indoor air, right? I mean, what's in the indoor air? I'm just trying to put some names here, like, does smoke end up, but to me, really, indoor air is a cocktail of everything. What's happening outdoor, which we bring in, and also what happens indoor, with things like cleaning, and the human element. When we talk, we exhale. So indoor air is really a cocktail of all the pollutants from indoor and outdoor. Some of them we could see, like we're trying to show you on the picture, just across the sunbeam, but most of them we cannot see, and that's what really poses a greater risk to occupants. Just look at what are the guidelines. The WHO updated its global air quality guidelines, what is called AQGs, in 2021, and these highlights the 5 primary airborne pollutants that it considers most hazardous to human health based on current scientific evidence. You may have or heard about PM, which is the particulate matter, or in a layman's term, we could say it's a dust particle. So particulate matter equal to or less than 10 or 2.5 micron is highlighted by WHO as being particularly hazardous to occupant health. They can penetrate deep into the human body via the bloodstream, damaging organs such as the heart and lungs. And if you see further, if you look at PM1, for example, which is highlighted in red, it even goes further into lungs. So we'll talk about that. But smaller the PM, dangerous least as it gets deeper into our systems. The World Health Organization recently updated, well, I say recently in 2021, the updated guidelines shown in this table recommends much lower levels than 2005 edition. So certainly that matters, and it's one of the area WHO is actually working on. And these changes are really based on the research finding from the past 15 years. The recommended safe limits and exposure times, the WHO air quality guide shown here, apply to outdoor and indoor environments and cover all settings. Just a little note here to the way the particles expressed here are, these are expressed as particulate mass concentration or microns per meter cubed. So micron being a thousandth of a meter, which signifies the quantity of particles in a given volume air. So that just a number of particles per meter cubed. Are there any target dates? I mean, I know next week in Switzerland, WHO is holding a big IAQ kind of conference, but really the interim target from the table on the previous slide taken for the air quality guides are proposed by the WHO for application in areas of high pollution where government seeks to improve air quality. The aim for them is really, and for us, is to promote continuous improvement over time, since this is likely to provide greater health benefits rather than a single rapid cut pollution, in pollution at an unspecified later rate. And that's one thing we realize, that indoor air quality is a continuous process. Just a quick note to note that in the WHO guidelines, it does not cover bioaerosols such as pollen, fungus, mold, and viruses. However, these airborne pollutants have a significant impact on occupant comfort and health. So it's very important for us to consider as within the IAQ expert or building managers to address these virus and bacterial pollutants. This time we just look at the sizes of these bioaerosol particles. Like other pollutants, these particles vary in sizes and can be extremely small, as shown on this diagram. So if you look at typical allergens, common spores, which is 2 micron or 10 micron, versus you look at the bacteria and viruses. So viruses, you notice, are typically less than 1 micron, and unfortunately, these smaller pollutants are more difficult to remove from the air in indoor space, as they are too small to be affected by the general air movement. We just added another column right there, which talks about the settling time. So these are an average settling time. So if you look at the allergens, 1 to 6 minutes, versus viruses from 1 second up to 13 days. So the longer these particles or viruses remain in airborne, the more likely they will be inhaled or spread throughout the occupied space. Therefore, it's essential to consider the amount of pollutants in a space and how quickly they can be removed. Mechanical ventilation typically are well suited to remove particles of 1 micron or larger, but the real challenge is around the smaller size of the particle. So just as a context in terms of what we're looking at in indoor air. This slide might help you a little bit more when we talk about particles and PM 2.5, right? This is just a visual, really. And it gives a good indication of relative size of particles and type of materials. If you look at, if you look at hair, that looks like a dinosaur tail, but it's really kind of human hair, 50 to 180 micron as average, about 120 micron. So, we can feel our hair and touch it. And if you drop it, it drops on the floor because it has a weight, right? But then if you come down, this really gets nasty dust particle, PM10. You may be familiar with red blood cell. And then PM 2.5. And then you look at less than PM, or PM1 is bacterium, wildfire, smoke, coronaviruses, Zika virus, real nasty stuff. It's all in here, right? So I think it's a good indication and good slide to just give us what we are talking about, right? This illustration from NAFA, the National Air Filtration Agency, and this is also referenced in ASHRAE 2022 IAQ guide. Really what we're looking here is a typical distribution of particle by weight and how that impacts in terms of removal. So if you look at here, we're looking at the particle size, particle size in 30 micron, 10 micron, 5 micron, 3, and so on. I'm just gonna get my, okay. So what we're looking at on the left-hand side, the micron size, if you look at the percentage by particle count and look at the less than 1 micron, which is 98.5, right? And look at the weight of those particles. So if you see here, the particle size is less than 1 micron, the percentage by particle count is 98.5 versus the weight is only 3%. So this is done by a number of studies, right? And makes us think, wow, 99% of those particles are less than 1 micron, and they are only 3% purely because they are weightless, right? So because they are weightless, they hang in the air. So things like, for example, if I may say coronavirus, SARS-CoV-2, is typically less than 1 micron. So the challenge is they hang in the air, they're suspended in the air. So the general ventilation flow cannot impact them, and that's was the challenge we had, during the pandemic. So this just to kind of give some context in terms of some of the recent findings and some of things have been highlighted by various organizations. So we briefly looked at what is the indoor air quality and what are the different challenges. What can we do to improve the indoor air quality, right? For us as GPS and for us, it's important always to control at source. So think about what can you do to remove the particles at the source. So very basic things like in the office, carpet cleaning, using the cleaning material, things like that. They produce VOCs, for example, right? So versus doing any other thing. So always think about controlling its source. That's your best thing, right? Ventilation, it's important, that part F of the building regulation sets standard ventilation. We achieve that, that's the basic. And then we apply an optimized air cleaning technology. We apply the air cleaning technology with a view that, can it remove or reduce the ingress of outdoor pollutants, and also significantly reduce the number of particles in the space, because we saw on the previous some of the slides the number of particles hanging in the air, right? So that's really kind of approach we look at and recommend. Just before that, I think it's kind of good to cover some of the sections of the filters, right, and importance of the filters. Now, filter selection can be a bit challenging and for non-specialists. And I've been learning myself over the last few years, but it's a field that become increasingly sophisticated over the past few years. For example, if you look at ISO 16890, it established standard test criteria for filters and certifies them according to their efficiency at capturing PM1 or PM2.5 and so on. And that efficiency is known as resistance, and which indicates the percentage of particles a filter captures, and it's shown in the 5% increment. So for example, EPM10 is talking about PM10 with the percentage figure showing could be 80%, 95%. So when you look at the filtration efficiency, they'll have a fine print explaining about that. Also, the quality of outdoor air will have a significant impact on indoor air quality. So this should be accounted for when specifying filters. Eurovent has provided the guidance on filter choices in 2022 publication section EN ISO 16890. The guidance highlights 3 categories of outdoor air shown here. These are based on the level of particulate generally present in it, and measured against the WHO guidelines. So really talking about what's the outdoor air, and based on that you define your filter selection and consider to improve the indoor air quality. Eurovent outlines 5 levels of supplier standards measured against the WHO air quality guidelines, which are shown here. While it might be interesting to see, we have a levels of 5, but which might be unrealistic for us to have that, right? Because it talks about the PM2.5 and PM10, which exceeds the WHO air quality guidelines by a factor of 1.5, which are much higher than the WHO recommendations. But these are typically for places like car parks or rubbish place removals. So this is still important, right? To note that the category 1 is typically reserved for the clinical the clean room environment. So typically your level 2 or 3 or 4 is more for commercial environment. And again, it's based on the WHO guidelines on the factor of PM2.5 and PM10. just look at a little bit at the optimized air cleaning and what are the important steps. Perhaps you're familiar with the HEPA filtration and ultraviolet light, right? So again, filters covered by ISO 16990 captures particles of 1 micron or smaller. What can we do to tackle those important submicrons particles? HEPA filters are one option. They're covered by EN standard and can capture particles down to 0.3 microns. The challenge or the disadvantage with HEPA filters are it can be relatively high capital cost and high life cycle cost. And when positioned in the ventilation system, they increase the operation and reduce system energy efficiency. And also if you think about the less than 1 micron, which are hanging in the air, they're not moving. So that makes HEPA filtration and passive technology. Similarly, the ultraviolet options are also able to tackle the submicron particulates. However, UV is not a true filtration method. Instead, the UV light destroys the particles. It is generally considered more effective for medical environment and clean rooms. A disadvantage really kind of for HEPA and UV system is that they are passive solutions, relying on the ventilation system to get the particles out of the occupied space. So if you think about ultrafine particles less than 1 micron, which is weightless, which is hanging in the air, it's not moving because of the general ventilation flow is not enough. So HEPA filters UV are sitting in the system waiting for them to come to them, right? So they're considered as a passive technology. This is where we kind of bring in another method to overcome this issue, which is ionization. Ionization is an active approach to cleaning the air within the occupied space. Within ionization, the ions flow through the ductwork in the space, and these ions attach to the particles, make them bigger, and push it to your filters. By doing this, it complements your existing ventilation and filtration, and it's part of a layered IAQ strategy. The important thing to note that ionization requires airflow. So ions will actively clean the ultrafine particles, in a clustering way, and we'll see in some of the other slides. I just like to show this slide. This is really a model presented by Dr. Ian. It talks about the layered approach to IAQ. So basically, it talks about not one single strategy can give you 100% optimal performance. So here, looking at the adding different layers and ionization technology, what we're going to talk about is part of a layer approach. It's not a silver bullet; it's a layered approach to mitigate the risk. Right? That's what we talk about. So here, if you look at shared responsibility, for example, there are a number of things we could be done at personal and public level. Again, the idea is to mitigate the risk. And what can you do to minimize the infection or prevention of infection? So ionization is part of a layered approach. Just looking at a couple of slides, if some of you are not familiar with the principle of ionization, but basically ion is a particle. It's an atomic molecule or a group of molecules. They will either have a net electrical charge, and ions are naturally present outdoors. So when I carry my ion meter, I can actually measure the ion count per cubic centimeter. So ion cannot be seen, but it can be measured. And importantly, ions are created from movement of water and lighting. So again, ions are naturally. Typically, ion concentrations are higher in a natural environment. So things like woods or waterfall is a great example. If you go near waterfall, the running water creates loads and loads of ions. So you can see ions in concentration of in excess of 20,000 ions per cubic centimeter. So cubic centimeter being a third of a die size. But when we come to the city or urban area, we pollute the area by a number of domestic, commercial pollution, and the ion levels drop. So typically we look at the much lower ion levels in the space. So all we are suggesting with ionization here is to increase the ion levels. So in a way, bring in the waterfall in the area. So what does ionization do? So it creates an effect of agglomeration, or basically a cluster. If you look at the smallest particle which hang in the air, they don't move with the ventilation flow. These ions coming through the ductwork, through the airflow, they're attached to each other by the principle of electrostatic pressure. So by attaching, they create a cluster, makes them heavier and more susceptible to the air movement. So as you can see here on the slide, the smaller ones become a big cluster, and now they carry weight. Because they carry weight, they would be usually sucked back into your filtration, or they will drop on the floor. So now, by adding a layer of ionization, you're actually vacuuming those ultrafine particles, right? You're getting them out and having them captured into the filters, and this is how it complements your existing ventilation and filtration systems, and makes it even much better. So, benefits of ionization: this could be applied in new and refurbishment projects. So it enhances the performance of the ventilation systems. It works on particles in the air and higher surfaces. It reduces the VOCs and odor. Important thing when we talk about ionization, and understand the difference between soft ionization versus hard ionization. And this is one of the challenges we always come across as an industry, as a manufacturer, as a group of scientists, not me, but some of the scientists sitting on our board, is the ionization could produce ozone or byproducts, but not if it's done in the correct way. So what we're really trying to just differentiate here is something called soft ionization. The soft ionization releases ions at a lower energy, and these ions, as they go in the air, all they do is attach to an electron or take up an electron. They don't break the molecule. So all we do is attach. By doing that, we deactivate the particle. So if it is, for example, just for the sake of example, if it was a SARS-CoV-2 particle which is hanging in the air, it will attach, deactivate them, and then eventually make them bigger and breathe out. So if you look at hard ionization or some of the plasma technologies, then it does break the molecule. And when you break the molecule, you produce ozone and some of the byproducts, which is not required. So just a very brief. And there are some references here available, or I can send later if somebody has interest to read more or understand more. But very key difference, that soft ionization is better for IAQ. Again, it charges with the low energy exon particles without breaking them down, meaning no fragmentation, no byproducts, and importantly, no further ultrafine particles were created. For example, a GPS needlepoint bipolarization uses carbon fiber needles, so it cleans the mechanism itself. So again, once it's mounted, no replacement parts or virtually maintenance-free products. Again, it's important to avoid hard ionization for the fact that hard ionization uses high energy, which breaks down the particle, and by breaking down, actually you create more ultrafine particles and byproducts. Actually, clearly has some guidance on ozone. In the low atmosphere, it's an undesirable product because it could have impact in respiratory conditions. In the upper layer, in the earth, that's better because it avoids it prevents the UV rays coming through on the earth. So actually has a standard which is called UL 2998, which talks about all the indoor air quality technology like these should be labeled in accordance with UL 2998, which is basically has a threshold of 5 parts per billion, which is considered to be a zero ozone standard. Ionization can be applied in any indoor space as long as you have an airflow, be it domestic, commercial. Importantly, with ionization, what is important is how many ions you get in the indoor space, because more ions you get in the space, better they target the particles. And like I mentioned before, you could measure the ion density with the ion meters or some of the other capabilities. So you can do before and after measurement, which is very important for perhaps yourself and the customers. Some of the points to consider when you're applying the ionization. So ionizers mounted too far from the occupied space could have less impact. So what we have seen during a number of tests and in the real world, typically an ion lasts for 60 seconds as an average. So by the time they're consumed, they are kind of deactivated. So our suggestion is to mount the ionizer module as close as to the indoor space, and make sure you have the airflow, and also look at if there is a complex airflow plot that might have an impact on ionization. It's not end of the world, but just something to consider that further you mount the ionizer, less the less ions you get in the space, and it might make sense to mount them close to the space and get more ions in the space. Yeah, like I said before, I think IAQ is a continuous process. It's not just one day and in and one day out. So it's not a single point objective for designers or building managers or owners, right? Constant monitoring and management through the room sensing devices that report IAQ condition space are available in the market. So there are a number of manufacturers make their sensor available where you can measure the different level of IAQ parameters, things like temperature, humidity, VOCs, PM levels, and so on. Certainly, ventilation is the backbone of IAQ system. Filters are a necessity, and ionization is an active technology that enhances the system performance. So again, ionization is an added layer, which complements your existing ventilation and filtration system. So yeah, I mean, the time to address the IAQ is now, right? There are no legal minimum IAQ standards for most buildings in the UK. However, the growing awareness of the impact of air on our health and well-being is creating demand from building occupants and managers for solutions. So, and importantly, the progress of the Clean Air Bill, good air quality may soon be a right that people expect both outside and indoors, including soft ionization technology as part of the ventilation and filtration system gives building managers confidence that the air occupants breathe is free from even the smallest and most potentially hazardous pollutants and viruses. So with this, I conclude my presentation. I tried to kind of keep it very brief. Matt, if you have a question, I'm open to take the questions, please.
Alpesh, thank you very much indeed. Very insightful. And yeah, some of the things that you presented there, we discussed previously, and particularly around the concerns around ozone. So I'm very happy to take any questions. Julie, I'm unsure if we've received anything in the Q&A. I can't see anything in the chat, but over to the floor for any specific questions, please.
Nothing as yet. So if anyone wants to ask a question, if you can raise your hand, we can also unmute you and you can ask it verbally, or just pop it in the chat or the Q&A. We'll pick up both.
And if you want me to go back to any of the slides, I know I kind of run through. So if you want me to go back to any slides and talk a little bit, or address that, then I'm happy to do that as well, please.
Sure, thank you, Alpesh. I guess whilst people are thinking, maybe just to recap on some of the discussions we had previously. One of the things that we found in our organisation and generally in industry was, even though we've been talking about indoor air quality for a number of years, innovative technologies such as NPBI is still relatively unknown and therefore relatively unproven, and the standards that govern what good looks like are maybe not quite as mature yet. So we still feel like, even though it's been around for a while, that we're possibly in the early adopter phase. Is that fair?
I think in the UK and Europe, I would say yes, that's fair. I mean, if you go back to US, this technology has been there, it's been adopted, it has a federal grant, EPA will recognize it. But UK, Europe, I think, yeah, that's very fair, and that's one of the challenges we find as a manufacturer, that we need to be aware of what this technology is, and then take the element of misunderstanding or conception and bring the science to the front. But I would agree with your statement there, Matt. Absolutely.
Thank you. And I think we've got a question in the chat. And I'll read it out.
Sure.
So it's from the perspective of IAQ, how have you found that businesses have changed the way they view it, or the introduction of equipment to ensure that it's better?
Yeah, so certainly, IAQ, if you think about from industry perspective, you may have seen all the exhibitions and conferences now within HVAC, they talk about IAQ. There's a segment about IAQ. There's a specialist conference about IAQ, right? And things like that. So if you think publicly, government, everybody's trying to do something with IAQ, that's one thing. I think the perspective in the end, when, why do I put my hand in the pocket, right? If I'm a building manager or a facility manager, I think that's really where it comes down to a challenge, because there's no legislation, I don't have to do it, right? And then it comes on to nice to have, there are certain organizations who understand and apply that and go ahead with that. But it's really that challenge that, not having legislation or standard versus something nice to have, right? It's a challenge, right? And also the other thing I found is really, because we can't see the air, right? And there's kind of lots, we can't see the air. It's very difficult for somebody to get up in the morning and say, oh, my air is bad or whatever, right? So that kind of puts it behind in terms of, I may say, kind of priority, not consciously, I suppose, but unconsciously. So it becomes a nice to have in the end, right? Because then people, the one thing I always find is how do I measure, and we have done a number of case studies, and as you mentioned, pilots for people to understand what's in there and what are the changes, if that makes sense or addresses. But this is very valid questions,
Yeah.
and
I think Tony, thank you for your question, by the way. I didn't call you out there, but Tony did just clarify as part of that question, what changes do we see as a result of, for example, COVID, and how people perceive IAQ? And before you answer that, from my perspective, from looking at it through the lens of FM, I think there's from a customer perspective, we've certainly found that, particularly coming out the tail end of the initial lockdown phase, there was a real appetite to understand and have evidence that the maintenance of all of your ventilation and your HVAC system was in good shape, and that we could demonstrate that equipment and systems have been maintained as that layer of protection approach that you refer to, the Swiss cheese model, Alpesh. And
Correct.
then a demand to ask what's out there to help us better clean the air, or at least do something more, even if we couldn't quantify the exact benefits of it. And I think for me, there's still an appetite there for it. I think the challenge that I'll talk personally about, that I've had or we've had as an organization, is quantifying the benefits in terms of how much healthier or how much less risk is there by adopting this type of technology. And the way we've approached it is looking at the layer of protection approach, as you've already described in terms of the Swiss cheese, and almost presenting it as on a virus risk index, in terms of all of those protection, those measurements that you're making, and how that can translate into an increased or elevated level of potential risk. So if we can't quantify it specifically or scientifically, it's almost categorizing it to show that actually what we're doing is providing that healthier environment, which in itself is going to reduce the likelihood of the transfer of airborne disease or viruses.
Correct, Matt. Very well put forward. And I think Tony's point is I think one thing you if you're going to, you'll hear a lot about airborne particles, right? One thing COVID did is, if you think about the slide here, for example, where does the COVID sit, right? It's ultrafine particle. The challenge we had with COVID or something like those bacteria viruses they are spread human to human, right? So they are right where we are talking, we are breathing, meeting, right? And that's the challenge. How do we protect ourselves? Now, again, if you look at the cheese model, it talks about you cannot get 100%, but the point is, can you minimize and mitigate the risk, right? And we'll still continue with your normal operations. So technology like this, right, for ionization, addresses the core of that issue. One, because these bacteria viruses are in the breathing zone. So the ions, for example, come through the airflow and actively clean the breathing zone by deactivating those, right? And that's one thing people have started realizing if you context, and that's why you hear or read a lot about airborne particles, and lots happening around that. And I normally, when I do the in-person presentation, I carry some of the tools to kind of show them and help them understand, the calculation. And that's why, I don't know what environment you are in, but, a lot of people, a lot of employees are being, asking the employees, right, going back to offices, what is happening, what are the measures being taken, right? So it has suddenly put it on everybody's mind, and especially, or unfortunately, if somebody's suffering from some sort of condition, then it becomes even important for them and everybody else around to protect them. So yeah, I think you minimize the source, and after ventilation, add anything like these, you are looking to mitigate the risk.
Yeah, thank you, Alpesh. And I think as you recall from our discussions as an engineer, I was looking for that evidence-based decision making, and as I mentioned at the start, we undertook a small pilot trial in one of our offices, and albeit on a small scale, we did see a marked reduction in PM2.5, but also TVOC as well. So somewhere in the region of, I think it was 30% and 15% reduction. So small, very, very small numbers to start with, but even smaller on the back of this type of technology. So it gave us enough to be able to demonstrate the effectiveness of it, but also then to quantify the potential benefits that come off the back of it. So conscious we owe you a further discussion about that.
And I think in the end, I mean, it's a challenge, but in the end, it's all about, we talk about well-being, right? And I think that's where it comes down to, health and well-being, and cleaner the air we breathe, better we feel, right? I mean, we probably all know that, and there are a number of scientific papers and articles, but you're right, that's a challenge in terms of always quantifying, and that's why we like to do those kind of pilots. And since then, we have done some of the other pilots, and we have seen, similar, results in terms of what it does to particles.
Super. Thank you very much. So we've had no further questions, I don't think. Julie, unless there's anything else that's come in that I haven't seen?
No, nothing else. Thanks, Matt.
Brilliant, thank you. So Alpesh, thank you once again. I think we're going to make the recording available on the IIRSM YouTube channel. Did we say that we were going to make the slides available? Forgive me if we did or didn't.
Yes, we can. No problem at all.
So if anybody would like a copy of the slides, they can request those. That'd be brilliant. Thank you very much. In which case, all that's left for me to say is have a great afternoon. Thank you once again, Alpesh. Really appreciate your time. Have a safe afternoon and good weekend when we get there, everybody. Thank you very much.
Likewise, thank you so much. Thank you and appreciate it. Thank you.
Bye.